Hello everyone, welcome back to my channel, and if you're new here, my name is Dano and I make content that relates to design, architecture, interior design, and lifestyle related content. So yeah, for this video, we are going to be discussing 5 interesting new building materials. Some of these are relatively new and some of these have been utilized within the past maybe like decade or so. But for the first material, let's go ahead and get into it. It is hydroceramics. So these are a composite facade material made of clay and hydrogel, and they are capable of cooling the interior of buildings by up to 6 degrees Celsius, which is roughly about 43 degrees Fahrenheit. And this is a type of technology that was developed by Spanish students at the Institute for Advanced Architecture of Catalonia in 2014. This material works as an evaporative cooling device, which reduces temperature and increases humidity. The porous structure of clay is what helps the hydrogel's cooling properties. This innovative material enables self-cooling systems, which are in great demand in the construction industry as well as architecture industry. These are especially popular for eco-construction, as it can save up to about 28% of the total energy consumption of traditional cooling devices. Hydrogel is defined as a type of soft material formed by cross-linking hydrophilic polymers. A polymer is essentially just a substance created by a series of similar building blocks that are bonded together. You can think of DNA, PVC, starch, and silicone, just as some examples of polymers. But these hydrophilic polymers are capable of expanding in aqueous solvents and retaining water. They can be molded into various shapes, and its properties can be altered in response to external stimuli. Hydrogel has the ability to absorb about 500 times more water than its own weight to create a building system that becomes a living being as part of nature rather than beyond it. Next up, we have, I'm not sure if I'm pronouncing this right, but it is Capcoma. And this material was developed by Komatsu Saiten's Fabrics Laboratory. This is a thermoplastic carbon fiber composite. So this material is created by braiding 7 strands of carbon fiber, and they are braided together with other glass fibers and then soaking them in resin. The rods are durable and they have low dimensional change with temperature fluctuations. These are resistant to rusting and corrosion, which in comparison to steel rods or steel tensile elements. For earthquake-prone regions, materials that can withstand these natural disasters are increasingly influential. Strands are roughly about 5 times lighter than metal wire of the same strength. Additionally, they have a really high tensile strength. These fibers are roughly about 9 millimeters in cross-sectional thickness, which for comparison and a sense of scale is the size or thickness of my iPhone 14 Pro Max. Next, we have a material called bio-coal lining. This was developed by a Berlin startup called Made of Air. This recycled material consists of 90% carbon and is able to absorb CO2 from the atmosphere, and itself is a carbon-negative material. This material is a special non-toxic bioplastic made of biochar, which is derived from forest and agricultural waste. It captures carbon and has several applications ranging from building facades, furniture, interiors, transport, and urban infrastructure. Made of Air combines the biochar with a binder derived from sugarcane that forms a material that can be melted and molded similar to other plastics. This is a porous, carbon-rich material, and it retains carbon extremely efficiently. Biochar also remains stable for an incredibly long time span and is cheaper than conventional bioplastics, but still more expensive than plastics derived from petroleum. Just for a quick definition, a bioplastic is a plastic that is derived from organic substances or biological substances instead of substances that are derived from petroleum. And many of these bioplastics are often biodegradable. Additionally, this Berlin startup Made of Air has incorporated this material into another form called hexchar, which was implemented in a project, and these hexchar materials are hexagonal panels, and they were first integrated as a cladding material at an Audi dealership in Munich in 2021. And through a life cycle analysis, it has been shown that the dealership's cladding will store about 14 tons of carbon throughout its lifespan. Additionally, the process of creating biochar is through a process called pyrolysis, which is the thermal decomposition of organic material in a controlled environment with no or limited access to oxygen. Next, we have a material called sensitile. Sensitile is a relatively new material that incorporates acrylic fibers in a substrate. This substrate can be anything from terrazzo to concrete to resin panels, and really any other material that can embed or have acrylic fibers embedded within it. So these acrylic fibers give the tiles the ability to transport light from one surface point to another via a process called total internal reflection. And essentially, in simple terms, total internal reflection is the interaction or the process of light or a light beam entering one material, and through the surface point or the intersection of another material, it will bend the light in a specific way. Well, there is a certain set of angles that you can use with different materials. Each material is different and each surface is different, so the angle required in order to achieve this effect will vary. However, it's essentially just aiming a beam of light at one material and through the surface or the surfaces of that material and other materials that are adjacent to it, it will bend light in a way that reflects it completely at the same angle that it entered at. When shadows fall upon the tile, they can be shifted and dispersed. And conversely, when light hits the tile, they can be refracted and reflected to blend colors and disperse light to appear as if it is twinkling. The optical effect that is achieved by these fibers and these tiles is inherent to the fiber itself, so there is no need to have an additional power source to cause this twinkling effect. Lastly, we have self-healing concrete. Traditional concrete is a reliable and well-established construction material or building material, but with that being said, it definitely has its own limitations. Limitations typically require additives to rectify issues that may arise. Concrete has a high compressive strength, but a low tensile strength, which is why if used without rebar or other tensile additives, columns are needed frequently to reinforce structural integrity. Concrete is also susceptible to corrosion from liquids and differences in pH. Concrete is relatively alkaline due to the presence of calcium hydroxide in cement paste. So, exposing concrete to acidic conditions will cause a chemical reaction where The concrete will then dissolve and deteriorate over time, and it can lead to cracking, spalling, and a loss of structural integrity as a result. In order to remedy this, one proposal was by an inventor, Hank Jones, from Delft University of Technology, where he showed an innovative method to repair cracks in concrete using bacteria of all additives or solutions in 2015. Capsules containing specific bacteria and nutrients for them to grow were added to the concrete, and the bacteria were then activated when water was introduced. Limestone was then produced by the bacteria, which filled the concrete cracks to rebuild damage. Additionally, an alternative to this was produced by Korean researchers, which includes capsules of a certain polymer, which were then added to concrete, where under the influence of moisture and sunlight, it began to swell and fill cracks. Now, just to clear up a little bit of confusion, I typically will hear a lot of people refer to concrete as cement. However, they are not the same thing. They are two different things. And whenever I hear cement, I typically will think of Portland cement, which is a component in order to create concrete. So Portland cement is created through combining and crushing different materials. So these materials are typically fly ash, limestone, and sand. They all have relative amounts of oxides within them, which are required in order to create cement. Once they are ground into a powder, they can then be added with aggregate. There are two different types of aggregate. There is fine aggregate, which typically is natural sand or crushed stone, so it is smaller in size and particle size. Then there is rough aggregate. Rough aggregate is a bit bigger in particle size, and they are typically larger pieces, so they can be like crushed stone, river rock, they can be granite chunks. Additionally, you can also use other aggregates in order to create a variation of standard concrete called lightweight concrete. And these will have different ratios, different other additives that are required in order to create this. And they're typically clay, shale, and slate, but they are combined with other materials. Additionally to the aggregate in Portland cement, there is water that will be introduced into this mixture, and that will then create a concrete mix, which you can pour into a mold or into formwork. And once it is allowed to cure through time and exposure to the elements or etc., then you will have concrete as a result. Now, there are also different ratios that you can incorporate these different elements in, and that will impact the finish of the concrete, the structural integrity or physical properties and capabilities of concrete. So there are a lot of different things that can impact it. So yeah, that's pretty much the three different elements: water, aggregate, and Portland cement. Well, y'all, I think that's pretty much all that I have for this video. So yeah, these are just 5 interesting new building materials that I found doing a little bit of research. Thank you so much for watching, and please like, comment, and subscribe, and I'll see you on the next one. Ciao!